equations of straight lines and equations of circles. So both of them are topics that are quite close together, and it's pretty important to know both of them to answer math questions for your GCSE math paper. By the way, just something you need to know. For GCSE math, you only need to know circles that have center origin. By that I mean the center of the circle is at the graph where the graph intersects, so the center of the graph, 0, 0. Because as we move into the equations for circles, you'll know that circles that have their origin in the center and circles that have their origins, say here, where it could be like 3, 4, they have different equations. And for GCSE, normal GCSE, you don't need to know this. For IGCSE, you don't need to know circles entirely. But if you do IGCSE Further math, you need to know this as well as this, obviously. Just to summarize that, for GCSE, you only need to know circles that have center origin. For IGCSE, you don't need to know any. And for IGCSE Further math, you need to know both. And none of the equations are provided, so you need to understand how they work, basically. So, first of all, distances between 2 points. And by the way, near the end of this video, you can see the different slides I have over here, right? I'm going to go through some exam style questions, helping you to just consolidate your learning. If you have this point, say 3, 4, and we have the point 5, 6, you can calculate distance. You can calculate this distance between 2 points, basically. It's not going to be 5 minus 3 giving you 2 and 6 minus 4 giving you 2. That's just the distance between the individual points. But if you notice, it's slanted, so it's not going to be 2, 2. There's actually a bit of a complex formula. Square root of 5 minus 3, so 2 squared, plus 6 minus 4, so 2 squared. It doesn't matter if you go the other way. So if you do 3 minus 5 and you get minus 2 squared, well, when you square a number, minus 2 times minus 2, that's going to give you the same answer, 4 anyways. So it doesn't matter whichever side you start with. And then you just do 4 plus 4, 16. Root 16 is 4. So the distance between these 2 points, this is going to be 4. Now let's look at proving this theory. How does this equation work? Well, if you have a triangle like this, you'll notice you can always create a right angle triangle. And for that, you can use a squared plus b squared equals c squared. Now, what you notice with all these equations of straight lines and circles is they almost always relate back to Pythagoras. As long as you understand Pythagoras, you can answer any equation, basically. So a squared plus b squared is where a and b are any sides of the triangle, and c is always the hypotenuse, the largest side, the side opposite the right angle. So this could be b and this could be a. The a and b's don't matter, it's just the c that always has to be the hypotenuse. Anyways, how does this equation work? Well, a squared plus b squared is c squared, right? Well, we can simplify that to become c is equal to a plus b squared, right? Square root of, sorry. Okay, you know what? I'll write it in the same order so that you guys don't get confused. A squared plus b squared equals c. Because c, we're squaring the answer that we get, right? So to get rid of the square, we can just root this side. So we can root it a squared plus b squared. How do you find a? It's the distance from here to here. If that was a and b. You could do it the other way around too. A and b. Well, this point is 5, this point is 3. So you're just going to do 5 minus 3 because it's a graph, right? This is a graph. And if this is 0.3 and this is 0.5, so the x is going to be 3 and x is 5, well, the distance here is going to be 2, right? So you do 2 here, and you do 6, so this is y is 4, so if you have another graph here, y is 4 and y is 6, well, this distance is going to be 2, right? That's why you get 2 and 2, square root, and you get the final answer, 4. Gradients. When you have parallel lines and perpendicular lines, you can easily find the gradient. By that I mean parallel means when you have two lines that do not touch each other infinitely, but they have the same distance between them at all times. This is parallel. So the gradient for parallel lines is the same. We often write gradient as m. So m is the same for parallel lines because they're facing the same angle. So of course the gradient is going to have to be the same. By the way, if you don't know what a gradient is basically the slope of the line. It's how steep it is. Imagine a ski slope. Gradient is how slope the line is. If you have parallel lines, they're going to have the same gradients, right? Meanwhile, for perpendicular lines are basically lines that intersect each other at 90-degree angles. You could have this being a perpendicular line. This could be a perpendicular line. This could be a perpendicular line if I drew it well. That's really bad. That could be perpendicular. This could be, nope, that won't be perpendicular. This could be perpendicular, but you get the point. If it makes basically an X-shaped sign with a right angle, it's going to be perpendicular. Perpendicular lines have their gradients multiply to make them -1. So if, say, we have the gradient of this line provided as being 1/2, this will always multiply with the gradient of the perpendicular line to make -1. How do you find the number that makes -1? You always just flip the fraction and you add a negative. If the fraction already has a negative, so say -1/2 is the gradient of this line, well then you don't need to add the fraction, the negative obviously, do you? So you just write 2/1. And you'll notice that they multiply, so -2/2, that's going to simplify to -1. So those the two gradients multiply to make -1. That's all you have to know for perpendicular lines. Midpoint formula. To find a midpoint formula, it's really simple. Say you're provided a line AB, and you want to find the midpoint. So that means the distance between A and the midpoint and B and the midpoint and B. So this distance and this distance will be the same. How do you find that? Well, let's say the point of A is 5, 4. I feel like I'm reusing the same coordinate, but it doesn't matter. And the point of B is going to be 7 and 9. All right? How do you find the midpoint? Well, you just do 5 plus 7 divided by 2, and you do 4 plus 9 divided by 2. That's your formula. That's basically not the formula. That's how you do it. You do 5 plus 7. It's going to give you what? 12 divided by 2. It's going to be 6. And you do 9 plus 4, 13 divided by 2, which is going to be 6.5. That's the formula. That's the midpoint of these two numbers. And you can double check that, right? What's the number between 5 and 7? It's going to be 6. So it's going to be middle. It's going to be 6. For 9, it's going to be 7.5. No, 6.5. Yeah. Right in between 4 and 9. How does this equation work? Well, basically you do x1 plus x2 divided by 2, y1 plus y2 divided by 2. Let's look at proving this theory. Let me erase all this crap first, just so that we can have more space for the actual theory. Well, if you have the 0.5 and 7, you want to calculate the middle of it, right? If you add both of them up and you divide by 2, you're going to get the middle number, aren't you? If you do 4 plus 9 divide by 2, you're going to get the middle number between them, aren't you? So that's why you add the x and the x1 and x2, you add them up and you get the middle number. Y1, y2, add and you get the middle number. The midpoint formula is like one of the easiest ones. You don't even need to do anything. It's just common sense, basically. Circle equations. Circle equations is arguably the hardest part of all three. These are just basic. You can relate them all to Pythagoras or just common sense. But circle equations can be quite a bit confusing to understand. Let's take a look at example. That's not what I wanted to add. Let me add a blank page. If we have, say, a circle that has center, or, okay, that was a terrible diagram. Let me redraw that. If, say, we have, this is going to be the graph, right? And this will be center 0, 0. The center is always 0, 0 in a graph. And you have a circle. Terrible. Let's just say that the center of the circle is 0, 0. If the center of the circle is 0, 0, the equation of the circle is always x squared plus y squared is equal to r squared, where x squared and y squared are just points on the circle, and r squared, oh my god, what am I doing? And r squared is the radius. This is pretty much just something that you're going to have to memorize, but I'll try to explain it in as simple of a way as possible. If you have, say, an x coordinate here, and y coordinate is going to be the same because it's a point, the y is going to be 0, right? You know the x, let's say the x is 5. If you have another point here, let's say, no, for simplicity's sake, let's put it along the y-axis. The y is going to be 0, isn't it? Well, x, yeah, no, sorry. The x is going to be 0, isn't it? Because we're on the y-axis. And let's say this is also, say, 7. Well, how can we use that to find the equation of this circle? Well, you can just do 5. You want to find the center of the circle first. That's what you always want to do when you have basically any circle. You need to find the center in order to find the equation of the circle. If the center is 0, 0, you know it's going to be like this in this formula. Because usually the formula for circles is actually x minus a plus squared plus x, y minus b squared equals r squared, where a and b are the coordinates of the center of the circle. But as you can see, we have center 0, 0, right? So for your GCSE students, right, this is what you need to know. The center is going to be 0, 0. So it's going to be just x minus 0 and y minus 0. So we can just simplify that to become just x and y, right? Because the center is 0, 0, so it's not going to have a difference. So it's just going to become x squared and y squared. That's going to be the coordinates of the circle. And r squared, the radius, by the way, from the center, the distance to all the different sides of the circle, are going to be equal. So you can just say all the equations are going to be just 5. Right? All the circles, because from the center, this diagram is pretty poorly drawn, but if you draw it like here, it's always going to be just, the distance will always be identical. Right? So that means the r squared, it's just going to be, say the radius of this is 3, we're going to just have 9. That's all you need to know. And how do you find the radius if we have this circle provided with us? Because the 3 is something I just made up, right? Well, we have 1.50, and we know that the center is 0, 0, right? Well, you can use the distance formula that we just talked about, Pythagoras, right? This, and then we can make a right angle triangle, and we're going to get a right angle, right? So we can calculate the difference in change in x, which is going to be 0 to 5. Okay, this diagram is really poorly drawn. I'll go through how this works when I go through the exam style questions, because that'll basically explain everything. Okay, so let's go through some example style questions. Starting with lines. Given that the equation of a line is y equals 2x plus 5, state the gradient of a parallel line. What did we say? If we have parallel lines, the gradient is going to be the same. So if you have y equals 2x plus 5, you have 2. So the m is 2. Gradient is always the same if it's parallel. However, if the question said 2y equals 2x plus 5, that's the gradient, that's the equation of the initial line, and we want to find the equation of a line that's parallel to it, don't write 2. That's a really common mistake that students make. Do not just write 2. 2y. The equation of a line always needs to be in the form y equals mx plus c, where c is the y-intercept, m is the gradient, x and y are points on the line. So if y is 2, then this needs to be divided by 2. We always need to make it into the form y equals mx plus c. Divide by 2. Everything needs to be divided by 2. So 2x becomes 2x, 2 divided by 2, which becomes x, because 2 divided by 2 is just 1x, but we don't write the 1, right? So it just becomes x, plus 5 over 2 will be the y-intercept. By the way, the y-intercept is basically just where the point where the graph crosses the y-axis. So if the equation of a line is, say, y equals 5, that means the line is going to be straight along the point 5. Because y is always going to have to be 5, so it's going to have to be parallel, straight like that. If the equation of a line is, say, x equals 3, it's going to have to be straight like this, because it's going to have to be always on the x coordinate of 3. That's how it works. Okay, next question. The points 0, negative 1 lie on a straight line now. So these are the points on a line. To find the equation of a line which is parallel to L and passes through the point negative 2, 0. So this is what I was talking about. 0 and negative 1. 4 and 5. We want to find the equation of the line, right? How do we find the equation of this line? What equation? We just need to find the gradient of the line. We just do change in y. Let me write this in the simpler form. Change in y over change in x. By the way, this triangle symbol just means the Greek symbol for change. So you'll see this in many textbooks. Change in y divided by change in x is the gradient of the line. Why does this formula work, and where does it come from? Well, if we have a line, say here, we want to find the gradient of the line, right? Usually you'd go 1, 2, 3, and then you go up. So you do, if you went up by 3 blocks, and you went right by, let's say, 5 blocks, the gradient of this line is going to be 3 over 5. So that's going to be the same thing in just a formula form. You don't need to draw the graph. Change in y over change in x. So change in y, 5 minus 1. That's the change, right? Actually, that's another common mistake. You have a negative and a negative. That makes it positive, right? It's not just 5 minus 1. It's 5 minus 1, which is going to turn into a positive 1. And you do 4 minus 0. That's going to be 6 over 4, which is going to be 3 over 2. Let me just go through this section again, because that might be a bit confusing for you. We're just trying to find the difference between negative 1 and 5. You don't even need to do the plus and minus if that confuses you up. How do you get from negative 1 to 5? You add 6, right? So that's going to be 6. How do you go from 4 to 0 or 0 to 4? 0 to 4, it doesn't matter. It's going to be 4, right? And then you just divide 3 over 2. By the way, if you go from this to this first, so if you do negative 1 to 4, and change in y always goes on top, remember though? So change in y, negative 1 to 5, that's going to be, what? 6 still, right? And 0 to 4, that's going to be 4, right? That's going to be 3 over 2. But if you start from the right number, so 5 minus 1, we're going to have to go minus 6 over 4 minus 0. So it's going to be negative 4, right? But minus and minus cancels out, so that's going to be 3 over 2. Just make sure you start from the same side. Anyways, you can do all that, and you're going to get the m of this line. Let me just erase all my working out so that I can have enough space to write. M of this line, straight line L, is going to be 3 over 2. Parallel to L and passes through negative 2, We're not finding the equation of the line parallel to it. We're finding the equation, not just the gradient. So the gradient of the same line that's parallel to it is going to be also 3 over 2. But we have minus 2. How do you find the equation of this line now? Well, once we have the gradient provided, we just put it into the form y equals mx plus c. M is the gradient, x and y are just coordinates on the line, and c is the y-intercept. We just need to find c, the y-intercept, because we have y and x provided, and m is also provided. So we can write a new equation, substituting y and x with the coordinates provided. So y is 0, 0 is equal to mx, so negative gradient times x coordinate, negative 2, plus c, that's going to be the y-intercept. 3 over 2 times negative 2, that's going to give us negative 6 over 2 equals 0 plus c. You can move that over to the left-hand side to just get c on its own. So you can add 6 over 2 to both sides to get rid of this one. That's c. Equation of the line, y equals mx plus c, right? What's the equation of m? 3 over 2 and x. And c is, where was c? Yeah, 6 over 2 and 3 over 2 plus 3 over 2. That's the equation of this line. Next question. Our circle has center 5 over 2 and radius 5, 2 and radius 4. So if you're a GCSE student, you don't need to watch this. If you're a further math student, you need to watch this. If you're an IGCSE math, normal math student, you don't need to watch this because circles aren't even in your paper. Because for normal GCSE, you only have circles with center 0, 0. We need to write down the equation of the circle, right? This is going to be the part where it gets a bit confusing now. So the circle has center 5, 2. So the center of the circle, that means, oh my god, this diagram is absolutely horrendous. The center of the circle is going to be 5, 2. The radius, so the distance to the end of the circle, that's going to be 4. So that's the same in all directions. We need to write down the equation of the circle. Remember when I said x squared plus y squared equals r squared? This is only for circles with center 0, 0. That's because the full equation of a circle is x minus a squared plus y minus a squared equals r squared. But we can simplify that to just become x squared plus y squared because that should be b actually. So where a and b are the centers of the circle. But if the center is 0, 0, the origin, you can just simplify this all out, right? But now we have center that's different. So now we can just input the center of the circle into the equation. So x minus 5 squared plus minus b, right? So 2. So plus y minus 2 squared equals r squared. R is 4, so square that. That's going to become 16. Now, in the same way, if you have an equation of a circle provided to you, you can find the radius and the center of the circle really easily. Because you added a minus to the center, you just flip it up. So the center is going to be 5 and 2. You just flip the signs if you have a minus in it. And radius is going to be the square root of 16, 4, because remember we squared the radius here. Pretty easy, right? The line L is a tangent to the circle with the equation x squared plus y squared equals 169. That's the equation of the circle. That means the center is 0, 0. Tangent. That means circle theorems. If you draw a line through here, this is going to be perpendicular. We can use that so that if we find the radius of the circle and the equation of the circle pretty much, the gradients will be perpendicular. So they're going to multiply to make negative 1. Remember that, right? Perpendicular, the gradients multiply to make negative 1. So, the line L is a tangent to the circle with the equation x squared plus y squared equals 169. We can do root 169 to find the radius of the circle, which is going to be 13. The graph also conveniently provides us with the radius because center to here is going to be 13, right? But imagine you don't have the graph because that makes it a lot harder and you can kind of imagine. Improves your math skills algebraically. And by the way, if you ever get a question that doesn't give you the graph, always draw the graph. Just sketch it out because that really helps you visualize the things. At least if you're a visual learner like me, it really helped me. So root 169 is going to be 13, right? Because remember, this is going to be r squared. So if you root that answer, that's going to get rid of the square, giving us a radius. So radius of the circle is 13. That means this distance is 13. Now we have the center of the circle, 0, 0, and we have this point, 12, 5. That means we can find the equation of this line, and this line is going to have the same. So if we find the equation of the radius of this circle, right? More specifically, this precise radius, we're going to be able to find the m, the gradient of this line, right? And since these two lines are perpendicular, they're going to multiply to make negative 1. So we're going to have the gradient of this line too. And we have this coordinate provided, so we can sub in these equations to the formula y equals mx plus c, and we'll be able to find the equation of the line L. Let's get to doing that. So if you want to find the 0, 0, and 12, 5, how to find the equation of the line? First, we need to find the gradient. Change in y over change in x. Change in y over change in x. I should say x. Let's start with this one actually. 5 minus 0, 12 minus 0. I don't want to go the other way because that makes it confusing. 5 minus 0 is 5, 12 minus 0 is 12. You can also go obviously the other way. I'll just draw that just for simplicity's sake, just so that you completely understand. 0 minus 5, remember the y always goes on top, 0 minus 12. That's going to give us 5 over 12, negative 5 over 12, and the negatives cancel out so to give us 5 over 12. So whichever way you go, you're going to get the same answer. Just make sure you do 0 minus 5, giving you minus 5. So you went this way, right? So you have to go this way for the x coordinate as well. Don't suddenly go this way and do 12 minus 0, giving you 5, negative 5 over 12. That's going to make you get the wrong answer. Just whichever direction you go, you have to go the same directions both times. So that's going to give you anyways 5 over 12, right? And that's going to be the gradient of this line, the radius of the circle. It's specifically this one, 5 over 12. Just remember that in your mind. 5 over 12 equals m1. And if you have n1, we can just input a random point, and we have 12 over 5. So we can get y coordinate 5 equals mx, right? So 5 over 12 times x. It's going to be 12 plus c. It's going to become 60 over 12, which is 5. Simplify that to 5. Plus c equals 5. That's strange. I did something wrong. Unless c is 0. C is 0. We don't even need to calculate it. Minus 5 on both sides to give us c is 0. We always know that the c is going to be 0 already because this line goes through the origin. So that's going to give us c equals 0. So the final equation of the line is going to become y equals 5 over 12 mx. So we add the x plus 0. 0 is the origin. We didn't actually need to find the equation of this line actually. We just need to find the gradient. Because we're not looking for the equation of this line, we're looking for this one, and we only need the gradient from here. Anyways, let me just erase all that. That was just additional work. But if the question theoretically asked you for the equation of the radius, then you can calculate it that way. Now, we have gradient 5 over 12 of m1. Now let's use that to find the gradient of this line. And 12 over 5. Oh yeah, what am I doing? This is the final answer. Negative 12 over 5, we substituted that in with the gradient to get the equation of this line. Actually, no we didn't. No we didn't. We left out a crucial step. An absolutely crucial step. 5 over 12 is the gradient of this line, right? If you're keen-eyed, you'll notice it's perpendicular. Well, the question doesn't tell you, but if you have a tangent, so this is a tangent by the way, meeting with the radius of the circle, it's always going to be perpendicular, so it's going to make right angles. So 5 over 12, remember I told you initially, right? They multiply to make negative 1. I just used m1. Well, initially that was to calculate the radius of the circle, so equation for the radius, so that's fine. So what multiplies to make negative 1? You just flip the fraction and you add a minus, because that's going to multiply to make negative 60 over 60, which is good. Negative 1. So the equation of this line, the m of this line, is going to be negative 12 over 5. It's going to be m2. And then we can finally substitute this equation, this point, 12 over 5, because that's a point on this line, right? So 5, y equals mx plus c, right? 5 is equal to negative 12 over 5 multiplied by 12. I'll write that as a fraction just to help with the mental math. Plus c. We need to find the y-intercept of this line now. Well, 12 times 12, negative 144 over 5 plus c is equal to 5, right? Get rid of this to help with the space. Well, let's multiply everything by 5 to just get rid of this fraction. So it's going to become 25 equals negative 144 plus 5c. You add 144, 25 plus 144. Let me just do that quickly on my calculator. 169 is equal to 5c. So c equals 169 divided by 5, which is, there's no specific answer, it's just that. So you can make the final answer. Let me write that in red. Y equals negative 12 over 5, because remember they multiply to make negative 1. That's the initial gradient of this, but if it's perpendicular, they multiply to make negative 1. So negative 12 over 5x plus 169 over 5. All right, next question. Determine the distance between A00 and B. Exact value. Remember, if you have the points 0, 0 here, and then 1, 7, it's going to be somewhere like here. I'm just explaining the theory behind this, by the way, just so that you understand. So the equation will just be 7 minus, you can start anyway, 1 squared plus 7 squared equals 1 plus 49, root 50. Let me just explain the theory behind this. If you have A as 0, 0, B as 1, 7, well, the distance from 0 to 1 is 1, right? 0 to 7 is 7, and it's basically a squared plus b squared equals c squared, but we're just getting rid of the squared here, so it's going to be a squared plus b squared equals c. That's why we're doing this. That's where this equation comes from. You can just do this using Pythagoras if you want to, but this is much faster. Once you understand this, you can pretty much answer any question. Answer, root 50. Don't give it in decimal form, so don't simplify root 50 in your calculator to get, oh, by the way, root 50 simplifies to 5 root 2. But don't put the exact answer of like 7.07, something like that, because this isn't exact. It's going to keep going forever. So leave it in the root rule. Equation of circle x squared plus y squared equals 16. You instantly know that this is going to be x minus 0 squared plus y minus 0. That's the general equation. This is for center. So this, you know that this circle has center origin. By origin, I mean 0, 0. Just rewrite that 0. Circle C is translated by the vector 3, 0. So this is vectors now to give circle B. Find the center of circle B at any points of intersection with the x-axis. What is this question asking? If you have a graph here, and you have center origin and x squared plus y squared equals 16. So that means r is going to be 4, because remember, to find this, to get this 16, we squared it. So if you root that, root 16, you get the radius of 4. So that means the circle is going to go around, if I can draw it, it's going to have 4, 4, negative 4, and negative 4. Radius of 4, and remember, radius goes in all directions. Let me just rewrite this 4. Right? We're translating it by the vector 3, 0. Now, if I briefly summarize vectors, this top number tells you the direction, like whether it's moving right or left. This tells you if it's going up or down. This one's moving right, right? Okay, so let me just briefly summarize vectors. Vectors, the top number is left or right. Bottom number is up or down. It's pretty easy to remember because you go along the corridor and up the stairs when you write the coordinates, right? Along the corridor, the x, up the stairs, y. Same way, you write along the corridor, up the corridors, up the stairs. This is always going to be for the x-axis, this is for the y-axis. So up or down and left and right. If it's a negative, you're going left, positive, right. If it's positive here, you go up, negative, you go down. It's basically logic now. By 3, it means we're moving 3 to the right. So this is all going to shift to the right by 3. So this is going to become 7. It's going to become, no, this one becomes 7. The y will stay the same because you're only moving the circle right. It's not moving up or down. If this point was 0, 4, because the circle is origin, well, this point will now become 0, 7 because it moved 3 spaces to the right. If this was 4, 0, it's going to move 3 spaces to the right to become 7, 0. This will move 3 spaces to the right to become 0, -1. And this will move 3 spaces to the right to become 0. Sorry, that's not 0. -1 and 0. The y is 0. Center of circle B. Well, the center was 0, 0. But it moved 3 spaces to the right, so it's going to become 0, 3. That's going to be the center of the circle. Any points of intersections with the x-axis. Well, that's going to be these two coordinates, right? Well, that's moving to the right, so this becomes 7, 0 and -1, 0. That's it. Last two questions. M is the midpoint of PQ. Work out the value of A. How do we say we find the midpoint? X1 plus X2 divided by 2. Y1 plus Y. Let me write that in a much smaller way so I have enough space. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. Because if you add the x coordinates up together and you divide by 2, you're going to get the middle number. If you add the y coordinates and divide by 2, you're going to get the middle number, aren't you? So then, now we have M is 3a and 8. That might be a bit challenging to see, but that says 3a and 8, 4 and 10, and a and 6. We need to find the value of a. So initially when I first saw this question, I just thought this will be multiplying by 3 because a becomes 3a, right? So you multiply it by 3. So I thought you just divide by 3 again here to get a, but that's not how you do it. You can actually just solve this algebraically. X1 plus X2, right? So this was X1 plus X2. So 3a minus a divided by 2 is going to be the same as 4 minus a divided by 2. Sorry. No. That is not what you're supposed to do. 3a minus a. So we have the common number of 3a, right? Let me just rethink this. I'm almost forgetting how to do this. If you think about it, you can find the answer because it requires a bit of hard thinking. So you have 3a and a. How can you relate that to the number 4? Because you have to use this 4 because that's the only number that you have for reference. 3a. How did we get 3a? It's the midpoint. So 3a minus a and 4 minus a. How did we do that? 3a minus a, 4 minus a. You know what, let's just come back to this question. I'll think about it and I'll come back to it. The straight line L1 has equation x plus 2y equals 4. So that's the equation of one line, x plus 2y equals 4. The straight line L2 passes through the points -1, -7, and 7, 9. Are these points perpendicular? So first we have the line of L1, which has the equation x plus 2y equals 4. Let's write it into the generic formula of y equals mx plus c, where x is the x and y is the y coordinate, m is the gradient, and c is the y-intercept. Let's rearrange that to become 2y equals 4, negative x moves here, plus 4. So this minus, we just minus x on both sides. This is the thing I said initially, 2y. It always has to be just single y, no, nothing. Divide by 2 on both sides. So y will become 0.5x, don't forget the negative, and plus 2. I'll just write that as -12x. That's the equation of L1. L2, we have these points, so we can find the change in y over change in x to find the gradient of L2, and you can use that gradient and input the x and y coordinates of either one, and you'll find the equation of the line. Change in y, 9 minus -7 will give us 2. Sorry, no. 9 minus -7, yeah. 7 minus -1. Minus and minus, they become positive, both of them. 9 plus 7 is going to be 16 over 8. That's going to be 2. Just in case you sometimes get confused with the minus and minuses, just use common sense. What's the distance between minus 7 and 9? Well, it's going to be 7 plus 9, isn't it? So it's going to be 16. Negative 1 to 7 is going to be 8, isn't it? So 2 is the m, the gradient. And you can use any coordinate you want to find the equation because they're both on the line. Let's use this one because it doesn't have negatives. I don't want to deal with negatives right now. 9 is going to be equal to, because that's y. Now we have the gradient, 2 times x, 7 plus c. 14 equals 9 plus c. Minus 14 on both sides, you get negative 5 equals c. That gives us the equation of y equals 2x minus 5. We actually didn't even need to find the equation of this line. We just needed the gradients of both lines because we're just trying to prove that they are perpendicular or they're not perpendicular. So you can have negative a half multiplied by 2. I'll write that as 2 over 1. If they make negative 1, it'll be perpendicular because remember, perpendicular lines multiply to make negative 1. Negative 1 times 2 is negative 2. 2 times 1 is 2. That's going to be negative 1. So they are perpendicular. He is correct. Let's go back to this question. I hope I can solve it now. This is the only question that actually kind of confused me. It can be quite confusing, and it was quite confusing. This actually took me quite a while to finally answer. To some of you, it might be really easy. It might just be the way that my brain processes things. But this question was really confusing for me. So you might be watching this video and just shouting the answer. Who knows? So I think we need to relate this. x1, x2 divided by 2. Right? So x1, I got it. x1 plus x2. 4 plus a divided by 2 is going to equal 3a. That means we can multiply by 2 on both sides to get rid of the fraction. 4 plus a equals 6a. We can minus a on both sides to give us 5a is equal to 4. And you can divide by 5 on both sides to give our final answer of a is 4 over 5. That's super easy. You just need to understand basically the concept that x1 plus x2. So this point plus this point is going to give us the midpoint. So once you just fully understand how this works, then you can answer the question. 4 plus a divided by 2 is going to equal the midpoint of 3a. And you just simplify and solve. Anyways, thanks for watching this super long video on equations and circles and everything. I hope this kind of explains everything. And thanks for watching.